Here is a photograph taken in 1927 that might be the most intellectually dense image ever captured. 17 of the world's greatest physicists sit together in Brussels. Between them multiple Nobel Prizes, the foundations of modern physics, and a disagreement so profound it would redefine reality itself. This was the Solvay Conference, and at stake was a question as old as philosophy: what is the world really made of? At the turn of the 20th century, physics seemed nearly complete. Newton explained motion, Maxwell unified electricity and magnetism, the universe looked predictable, elegant, mechanical. Then experiments began to contradict theory. Blackbody radiation, the photoelectric effect, atomic spectra. Classical physics couldn't explain what was happening at the smallest scales. In 1900, Max Planck introduced the radical idea that energy comes in discrete packets, quanta. In 1905, Albert Einstein proposed that light behaves as a particle. In 1913, Niels Bohr introduced a quantum model of the atom. The universe was no longer continuous, it was granular. By the 1920s, quantum mechanics was emerging, but no one agreed on what it meant. The fifth Solvay Conference was organized by Belgian industrialist Ernest Solvay, its theme electrons and photons. In attendance was Niels Bohr, Werner Heisenberg, Erwin Schrödinger, Paul Dirac, Marie Curie and Einstein. Never before and arguably never since has so much intellectual firepower gathered in one room, but the central drama wasn't collaboration. It was conflict. At the heart of the conference was a philosophical battle between Einstein and Bohr. Quantum mechanics, as developed by Heisenberg and Schrödinger, implied something shocking. At the fundamental level, nature is probabilistic. Heisenberg's uncertainty principle showed that certain properties, like position and momentum, cannot be known precisely. Bohr argued that quantum objects do not possess definite properties until measured. Reality is not fully determined prior to observation. Einstein was unconvinced. God does not play dice, he famously insisted. For Einstein, physics should describe an objective reality, one that exists independently of measurement. Bohr's reply was equally famous. Einstein, stop telling God what to do. During the conference, Einstein presented a series of thought experiments designed to expose flaws in quantum mechanics. Each time, Bohr responded, often overnight, defending the consistency of the theory. Einstein would propose a scenario that seemed to violate uncertainty. Bohr would show that once relativity and measurement were properly accounted for, the theory still held. It was not merely technical disagreement, it was a clash of worldviews. Einstein defended determinism and realism, Bohr defended complementarity and probabilistic interpretation. By the end of the conference, most physicists sided with Bohr. Quantum mechanics worked, even if no one fully understood why. The debates at the 1927 Solvay Conference did not end there. In 1935, Einstein, Podolsky and Rosen published the EPR paper arguing that quantum mechanics must be incomplete. Decades later, Bell's theorem and experimental tests confirmed that quantum entanglement is real. The universe is stranger than Einstein hoped, and perhaps stranger than Bohr imagined. Today, quantum mechanics underpins semiconductors, lasers, MRI machines, and quantum computing. But the philosophical questions remain unsolved. Is reality fundamentally probabilistic? Does observation create outcomes? Is there a deeper hidden structure we haven't discovered? The Solvay Conference represents something rare in history, a moment when humanity confronted the limits of its own intuition. The world at human scale feels solid, continuous, and predictable. The quantum world is none of those things. Particles behave like waves, observation changes outcomes, certainty dissolves into probability. The conference didn't just advance physics, it forced us to reconsider what knowledge means. Look again at the 1927 group photo. These individuals were not merely scientists, they were explorers at the edge of comprehension. They discovered that reality at its deepest level resists common sense, and in that resistance, modern physics was born. The Solvay Conference was not just a meeting, it was the moment when the universe became strange and we learned to live with it.